Welcome back. I'm Cody Henriksen. Today we're going to be taking a look at the CRUD of databases, specifically looking at the delete operation and how we can use it to remove data out of a database. Just as a quick reminder, when we're talking about the database operations, when we're working with CRUD, this is how we actually do the majority of our use of a database, especially on the user interaction side. And so with the C for create, we create or add data with the insert command. With reading, we're getting all that data. That's what we spent most of the semester working with, the idea of select clauses, where we're reading the data out of the database. We just reviewed earlier with the idea of updating data, and it's how we replace existing values inside specific fields. And finally, D is for delete. This is how we're going to take data out of it. This is when we're acting like a dog because we want to. All of the data. I know it's cheesy, but it's okay. So removing the data, this is what we're going to be doing. We're working on a row or record level. Again, remember that a record is another way of referring to a single row inside an entry of a database. So row, record, entry, these are things you'll be using on a regular basis or might see in different things you're looking at, like maybe the internet, textbook, etc. And when we're working about the remove structure, the first thing we have to do is we have to identify the table we're working with because we have to actually tell it where it's coming out. I know it's bizarre, but we have to. Now, although it's not required, we do have to use the where clause when we're doing a delete statement. We already talked about this when we were working on the update. It's not actually required for compilation purposes, but it really ought to be. We don't need to do the same Jurassic Park type of problem just because they could, whether or not they should. We really need to always have a where clause. It's just a default operation. We're not going to even do a demonstration using without it. It should be required. The next thing we have to really keep in mind, especially when we're working with the idea of a delete, is we have to keep in mind that foreign key integrity is kind of a big deal. We have to keep that in mind all the time. When we're working with the, foreign keys, the fact that we have relationships across multiple tables, we can't simply just delete things randomly across the structure, because if there's a reference in this table that's talked about over here, I'm trying to delete this one, this reference has to be updated first because I can't do any changes with, with this one until that's handled. So we have to make sure we keep that in mind before we do anything with it. And as well, we also have to make sure we keep the TCL language in mind. TCL, again, is the transaction control language. It's that subset of SQL that allows us to make sure that we don't screw things up too badly and allows us to rebuild things as necessary. And you can take a look at my TCL lecture for some more information on that. We have just a couple quick blurts about it here in this lecture, but that's where we can go from there. So let's take a look at the structure of the delete. So here we have the actual clause structure we're working with when we're working in a delete statement. So the first thing we have is delete from, which we identify what we're going to be working with. And then we have a table name because we have to tell it what we're talking to. And then again, we have our where clause. And whatever condition or conditions we're working with, we make sure we specify them there so we can delete the values as appropriately inside our structure. Remember, we always want to delete with a where clause, just an automatic default. The next thing we have is a delete demo. So if I want to go ahead and actually do a demonstration of how we're going to delete, we do the delete from, we specify the table name we're working with. In this case, it's grade conversion, and then where max grade is like 8 underscore. And so I'm using grade conversion on this because we've been working with the student database for the entire thing, but I can't just simply delete randomly out of the zip code table because although it's great for running random select queries that might mean nothing, because it actually relates to other tables, the student and instructor table specifically, I can't just delete from it randomly. So grade conversion has no references. There's no foreign key or primary key reference to it outside of it. So no big deal, I can just delete from it all I want. And so in this case, I'm delete from max grade like 8 underscore. Remember again that the like operator, when combined with the wildcards, it's looking for that value, in this case the 8 as the first letter of a sequence, and then underscore represents either 0 or 1 specific value after that. So it's either 8 on its own, just 8, or 80 to 89, because those are the values it could possibly be. So I'm going to take out the B's and one F, but no big deal. And that's how I can grade anything out of there. So all the B's have been removed from that grading system. So now it just goes A, C, D, F. Great, wonderful stuff, all great. And that's what we can do for that, so we can actually demonstrate that. We have another example right here, a little bit more advanced, where we're talking about that same problem where we have to actually have that foreign key constraint matched. And so we have right here, delete from zip code where zip like 100%, and then semicolon. So remember the percent on the, when using the like operators for the wildcard, it means anywhere from 0 to many. In this case, there's a whole bunch of, bizarrely, places that in New York City, 100 dot whatever, that have people in it. And in this, specifically in the student database, we have multiple instructors that live in New York City. And so that 100 whatever is a zip code we can't remove from. And so in this case, I have that error on the integrity constraint with my username .inst.zip foreign key violated. There's a child record found. So something in the instructor table, a child key reference of that is there. And so I can't do that delete. So I can't simply just remove data randomly out of a structure because I have to make sure I handle that foreign key constraint violation first. And we'll talk about that here in just a second. And I'll put that kind of a big deal. So like I said, we've got the idea that not only does Anchorman Ron Burgundy say that we have to kind of take care of this, we have to make sure that the primary key foreign key relationship, that foreign key integrity is a big deal. We can't skip past it. We have to keep it in mind. So here we go in a little more detail on that advanced delete. And so when we're looking at the dependencies, which is most databases and most tables, in fact, we have to make sure we examine the actual structure of that. And in class, we have the idea that I've got that lovely student schema. We've been looking at this schema the entire time, like, oh, here's how the student database is set up and how we're working with all the tables. You want to look at this all the time, because we look at removing from this, we want to see that there's relationships that exist between these tables. And we need to figure out what that relationship is. If we don't understand that relationship when we try and delete data, it's going to cause problems for us in the long run, because some of those dependencies are not direct dependencies, they're indirect dependencies. And we have to make sure we follow that along. So we want to make sure we follow that primary key, foreign key path we use when we're doing a join or a combination of table queries for a select clause. We have to make sure that same relationship is maintained. So we have to actually look across the tables and how they put together with that. And so one of the first things we do is, like, do we want to actually delete the value? Can I actually change it first? So do you want to change this foreign key reference right here to some other person or entity inside that other database? And so I can reference that. And then and when I delete it, like, oh, boom, I can make that delete because it's no longer being referenced inside there. So I can change the values that are referencing to it already. If I can't change it, then I have to delete those references first. And I have to make sure I delete them from the outside, working my way in closer to the table I'm working with. And those, like I said, those can be a direct reference where it's a foreign key reference, or it can be a foreign key to a foreign key, where it's like, oh, this table right here talks to this table right here, and this dependency right here is also dependent on that value right here. So I can't simply delete from this table. I have to go out here first, then delete this one, then come closer to this, and then I can actually delete the record I want to delete, because I've deleted all the dependencies that come existing before on the outer edge first, moving way closer in first. And that cascade approach is something we have to actually see when we're designing databases as well. We'll see this when we work about doing the DDL structure and working on creating databases in some of our later lectures. But when you're actually creating a database, you have to make sure you build them in the same approach. So you have to make sure that your outermost tables are built first, and then you can build the inner tables closer, because those because those connections generate upon each other and built upon each other, and we can't simply just delete or add to them already. So just make sure that each structure is self-contained as much as possible, and then build out from there, making sure we make those connections appropriate throughout the entire delete structure. And so that's what we have to do when we're working with the idea of a delete structure, making sure we maintain the data integrity of that foreign key relationship. We keep that in mind all the time. Use your ER diagram, keep it with you and work with it, so you can make sure you're making those delete statements appropriately. For our last statement right here, we have to talk about the TCL. Again, that's that transaction control language. And we're working with TCL. We want to make sure we identify all the pieces we're working with. And so the first thing we can do is make sure we do a save point before we do any deletes. By making that save point, I'm explicitly calling out, hey, here's where I want to be. Here's the thing I need to make sure I have done. Boom, save and give it a name. I can keep track of that. And then I can use a rollback to command, and I can go back to that previous save point if I make a screw up or a mistake, or I can make a new save point and, like, oh, I've got a new spot where I've made this point, and this is my new updated save point. And until I do a commit or a rollback, I can keep those save points built up and work with that. Take a look at the TCL lecture for more demonstration on how to actually use that, and we can see some examples with that. But again, you only want to use the commit for inside the database when you know you are finally done. That's the very last thing. But up until that point, just save point, save point, save point, only commit when you're done for the actual structure. And that's just a quick review of how we can use delete inside an SQL database. Hope this is helpful. Cheers and have a great day. See you next time. Bye-bye.